Hey, and welcome back to Blockchain, Cryptocurrency, and Web3 Foundations, module number 7 here. Holistic Web3 is what we'll be talking about today. As per usual, go ahead and grab something to take notes on. In particular, this week we'll be going kind of fast and wild through a few different topics. So I do hope that you have some questions that come up. Feel free to reach out to me in the class discussions if you do have anything, terms you don't recognize or content that you'd like more clarifications on. So we've talked before a lot in the beginning of this class about decentralized versus centralized networks. And this, I think, is worth coming back to because we've gotten pretty deep into what blockchains do. And the context here is that we want to build a dApp of some kind, meaning we use this blockchain in some web application somewhere, right? But typical web applications are the centralized model still, where we have servers that are centralized and a whole bunch of different clients that are talking to those servers. And that's where we're hosting from most of the time. But there's also different architectures we can explore where the blockchain can be more decentralized or distributed, as these two plots are showing here. Other non-blockchain services can have the same kind of network architecture. So we can look a little bit how we can use blockchain in coordination with these to provide a really decentralized app through and through. Your dApp can really live out in many different nodes on different services. So looking back at this DCS triangle, right, we have to pick a point somewhere here from centralized all the way out to this decentralized network and anywhere in between. So thinking about this, we really do have to make some trade-offs of some kind. And the first real model that I think we see very common happening, the oldest model actually, is this federated network. Email is an example of this, where we have many different email servers that all can communicate to each other, and we have email accounts that we can talk to through browser clients typically. So you think Gmail, right, is one, but you can have Yahoo Mail or Hotmail or AOL Mail or whatever it might be, right? They all talk the same language, it's all the same protocol, but different servers are your service provider. And you as a client can talk to anybody who has an email address, even if they aren't on your specific server, right? So this federated model is more typical than you might think, but has been superseded by a lot of centralized models because it's more easy to orchestrate. It's notoriously hard to run email correctly. If you try and run it yourself, it's definitely not for the faint of heart. But here, what we can see with this federated network is we have multiple semi-redundant, potentially central servers. So these servers can share information, but maybe they don't have a one-to-one copy. They don't come to consensus on this information, but they share the same language, right? So this generally provides more redundancy and reliability. There's definitely some security pros and cons. So it gets more nuanced here. We won't go into that in this course, but something to keep in the back of your mind. It's definitely more scalable because we have more service providers that can be out there in the world with many more users talking to these individual ones. The operational overhead, it really depends here, but it can be a pro and a con depending on how it's orchestrated and who you are, which kind of actor you are on this network. And harder to administrate, it's would lean heavier on harder to administrate in this sense because one central server that you can control everything on is much easier than just your server that happens to talk to other servers if you wanted to administrate the entire system. So another one that's more Web3 native, as we'll find out, is potentially the Fediverse is something you've heard of. This is something you can search for if you're interested. Mastodon is one of the clients that talks to this Fediverse in the sense of many different applications can talk the same protocol to basically replace some of the social applications you'll see. Mastodon in particular, I believe, is targeting Twitter. But instead of being a single Twitter server, we have many different servers that you can pick a home server on and all speak to different servers and share a Twitter feed effectively, something that looks like this. Another great example of this that I use quite often for work, this is where most of my chat goes on, is Element. This is a client that talks to a Matrix server that we host. And specifically, this Matrix server can talk to any other Matrix server. And beyond that, Matrix is really interesting. It provides bridging capabilities. So you're able to actually take your chat server and talk out to other chat services. So like the matrix can be bridged to Telegram or to Discord or to Slack or Mattermost or email or SMS, you name it, and it can talk the same language. So this is another one of these that's a federated, more email-like model for the server structure, but you can do far more abstract things. So something to check out if you're interested as well, matrix and element. So another one of these examples that's way back to the early days is IRC chat. So this is not very common unless you are deep in the weeds in the blockchain world. Some of the old crypto, cyberpunk guys still really, really enjoy this. It's still quite popular with techie folks because it is more common for people to latch onto this particular architecture. Another one of these, very many different choices that you can subscribe to as your service provider, and many different clients. So you can actually use different applications to talk to those servers, which is kind of cool. So if you want to see a very robust and well built out system, although admittedly it's not as user friendly and nice user interface as you might see in modern applications, this is one to check out. So moving more from this federated model, now thinking about decentralized networks more broadly, right? If we really do have no central server and we blur the lines between what a server and a client look like, these are decentralized networks. They effectively are all the same. We just have peers. We don't have a particular host that we're talking to that's any better than any one of our other peers, right? So this definitely provides more redundancy and reliability. Securities are definitely in the same light, out of scope, but very complicated when you get into this, pros and cons there. It is highly, highly scalable though, as long as you have the resources for each one of your peers to be an operator on this network. So you have to be careful about how you scale this, but it can scale very well. The operational overhead, as I was alluding to, you're processing a lot more information. These protocols and these networks typically take up a lot more bandwidth. They're very chatty. There's gossip protocols that go on these. So it's something to be aware of, where, for instance, running one of these applications that's really decentralized on a mobile phone might eat up your battery pretty quick and make your phone kind of laggy. They're pretty heavy operations for small devices. But that's not always the case, and it's moving into the future, they're getting more optimized. It's definitely harder to administrate. In fact, if it's really a decentralized, permissionless network, you can't administrate this ideally. At least a lot of these networks are going for this. So some examples here, I've put some logos up we'll go over. In particular, I'll point out IPFS down there. You'll be looking at that more in depth in the assignment in this module. So something to keep in mind. One really prime example of this that you might have heard of is Tor. So this is kind of synonymous for the uninitiated with the dark web. But it's not quite the case. Tor really is a network comprised of thousands of peer-run servers known as Tor relays. And so this is mostly a network, and this is why people think of it in the darknet sense, is to defend against tracking and surveillance of any kind of what you're doing on the network. So in plain net or clear net, you're making a connection directly to another peer, and the observers of those connections can figure out which computers are talking to which computers. Maybe they can't decipher exactly what's being said, but those connections are pretty well known, right? And so this is also a way to circumvent censorship. So here, to give you a very brief sense, if you want to find out more, please do check out the torproject.org. A Tor client, so your personal computer at home, can connect to the Tor network through an entry guard. So this is some node that is known and can be randomized for you, and then will pass along many different nodes within the decentralized Tor network your request for information in what's called onion routing. So only the entry guard knows to send it to the next middle relayer, and the middle relayer only knows that the entry relayer sent it to him and wants it to send to the exit relay, and the exit relay finally sends out a clear net request on your behalf. So as the network is structured, this obfuscates who's doing what on the network, so that your computer, your client, and your actual destination are very hard to be able to identify. If it's done well, it's effectively military grade in terms of what it's able to do. There's definitely a lot of caveats, but it's very well established. People trust this. So BitTorrent is another one of these you might have heard of. It's somewhat nefarious, maybe for hosting semi-legal content or things that are supposed to be DRM managed, digital rights managed. People can pass files peer-to-peer, right, is the idea behind this. So it can be abused potentially. But really what this does that is fundamental to how Web3 is going to really take flight and scale effectively is very efficient data propagation. If you've ever used BitTorrent, effectively what it's doing is setting a request from your client, your computer, out to the whole distributed BitTorrent network and asking for a piece of content. But in the pieces of that particular piece of content are sharded all across the network. So many of your peers might have the particular file that you want, and all of them can start feeding you pieces of this information. So if you're asking for a movie, if you've looked at BitTorrent clients at all before, it'll look for peers, it'll find peers, and then some of those peers will start streaming to you. So you could be connected to tens or even hundreds of different peers to simultaneously pass you this file. So it shares the load quite a bit. And this is probably closest to the IPFS protocol, which you'll be learning about a bit more, for peer-to-peer file sharing. And this is one of the more fundamentally important things when we're talking about blockchains. They're very bad for general data storage, whereas peer-to-peer file sharing like BitTorrent and IPFS are very good at this. So it makes a very good pairing that you'll see happen quite often. This is also, I should note, a censorship circumventing mechanism, right? Because you can share files that people would like you not to, and there's no real administrator here, so it's very hard to stop people from doing this. So kind of a wild tour of protocols. Again, feel free to reach out if you'd like more information or clarification on any of these things to give you a sense of what builds Web3, right? So those fundamental architectures can be plugged in to build new applications along with some interesting new technologies. They're hypey words, but things like artificial intelligence and machine learning, they really do play into the next iteration of the web, in which we can use these powerful new tools in combinations with these powerful new architectures. Maybe they're old architectures, but refreshed anew and done better with better engines to run them on, with computing systems that actually can handle the power that's needed, right? But we can do so much with this, right? There's a link here in the slides to 101 blockchains. If you'd like to dive a little bit into this, it's optional for them. If you guys would like to read into it a little bit more about their vision for what really makes Web3. But this idea of peer-to-peer and really enhanced connectivity across these peers is fundamental to this. Blockchains can really help be the trust layer to help make sure that operations are going on in an adversarial environment properly, even though people are trying to attack whatever might be going on in the network. And ubiquity, I think, is really important in the sense that we already see this, is your phone can effectively be running the same apps as your full power desktop. And for the most part, your user experience is pretty well, right? And it can be accessible across many different platforms. So this is cloud computing. We see this pretty often in the sense that I can share the same even virtual machine that if I'd like, and interface that with any of my devices. And then semantic web, I think, is really an interesting point to bring up here, is that basically the understanding of content is much more focused on the human interaction as opposed to the more machine type interaction. So being able to communicate at a more intuitive human-like level with your computers and computing systems is already happening all over the place with like Alexa and Siri. Sorry if I triggered one of them off for you. and so much more. And really, I think we already see a bunch of these changes starting to happen in Web3, is we have innovations that were not possible in the web of 10 years ago and were only dreamed about, really. So things are growing at a rapid pace. And I think that blockchain, as well as some of the things we're mentioning in this particular session, are important to follow as we're moving into what I think is powering Web3, all these different things that we're looking at here. But another really important facet of all this that might not be as strongly sung, and I'd like to encourage you guys to become aware of how important open source is to all of this. because really when we're having these distributed protocols, right, then we're supposed to be able to run this code. If we don't have any ability to audit this code or edit this code as we see fit, we're trusting someone to have written this and compiled it correctly is the first and most important problem, and then have no way to maintain it if those people go away. So open source really does power a lot of what I see as the fundamental building blocks for Web3 to work, and in particular, blockchains and trustless systems that really need to be open source for you to trust them in that trustless manner, so to speak. That's not necessarily the case with private and permissioned blockchains and software, but something to consider is that it's a core tenet of a lot of what Web3 is built around is open source. So what exactly does open source really mean? There's the open source initiative I encourage you to go check out, huge library of different open source licenses that you can apply to this. But basically it's talking about, can you view or edit or run the code? And all of those can be nuanced depending on which particular open source license you have. But open source most definitely isn't free, and free isn't free beer, right? You can potentially use the code. The license might guard in particular circumstances, might just let you view it. But people are definitely putting blood, sweat, and tears into building this stuff, just like any other software. So something to keep in mind, right? And again, as I was saying, the decentralization, being able to trust that this program is doing what you think it's doing is important. And then for resiliency moving forward, if the original company eventually goes away, the community can take it up. And security, it's a dual-edged sword in the sense everyone can see the source plain text. So there's no security by obfuscation in the sense that no one knows that there's a bug. So no one is able to trigger it. Now people are much more able to see these things and presumably fix them. Is the idea. So you're not hiding things behind a curtain, so to speak, but you still can have strong security assurances. But I was mentioning, right, free is definitely not zero cost, right? So how do we fund these things? In particular, we were looking at that last slide, some software you might recognize like Linux, for instance, is totally open source. And that's massive. It's powering most of the computers in the world today. Maybe not your computer at home, but most of the servers and IoT devices and things that we use very, very frequently and talk with very frequently, right? So where does all the funding come for this stuff, right? There's sponsorships are definitely one of these models. And we'll see this in GitHub sponsors is one of these open source repositories. If you're not familiar with GitHub, I encourage you to go check it out. They have a sponsorship program that is, depending on the project, individuals supporting individuals out to full companies at an enterprise level supporting in very high amounts for companies effectively that are dedicated just to open source, and more on a smaller scale, Patreon and similar type places there. In a Web3 native world, though, one project that I very much am fond of is Gitcoin. This is a project that was started up in Boulder, Colorado, so it's close to home for me at least. And they have a lot of interesting initiatives. Their call is to fund open source and make open source sustainable, right? That's what Gitcoin is all about. So there's grants for projects that are crowdsourced from the community to power different projects, as well as bounties then to fulfill different tasks. So if an open source project has a need for some software to be worked on in some particular way, they can go to GitHub and post an issue and assign value to this. In this particular case, it's primarily Ethereum or Ethereum-based tokens to perform this task. And there's on-chain mechanisms to make sure that these bounties go as planned, and arbitration mechanisms and all this stuff there. And then a whole bunch more. So I encourage you to go and check out Gitcoin if you're interested more in how do we sustain open source. With that, that's it for this week. We definitely explored some complementary technologies to blockchain, and I think that it greatly enhances the value proposition and also really powers a much more decentralized internet architecture for the entire web. So we can have much less reliance on these central parties. And hopefully it will be more resilient and secure and robust as we move forward because of this. And with that, Actually, next week we will be going back to having a guest lecture. So I encourage you to go into the announcements. There will be a link to RSVP for the GeoWeb, and that'll be happening next week. This is an augmented reality platform that uses NFTs and tokenomics based on those in a hybrid metaverse, meaning it's a world that lives on top of our own in this augmented reality space. So we'll have them come in and talk to us about their project as well as give us a brief demo. So looking forward to hopefully see you in person. And if not, we'll have a Zoom option for you there. So you can stream or you can record it. We'll record it and you can watch it later. All right. Thanks all. See you next time.